Hey guys, welcome back. So today we're working on this Generac GP6500. From looking at it, it looks to be in excellent condition. There is no rust, no sun fading, and it's very, very clean. I would say almost in new condition. Of course it's not. According to the date here, it actually meets the 2012 emissions standards. So, this machine is about 13 years old, but according to the seller, it had a very low hour count. There is an hour meter here, and of course, it doesn't work. These only last about 10 years. So we don't know the actual hours on the machine, but I tend to agree with his assessment. This machine, I think, saw very little runtime. Anyway, he went to start it recently, and something broke. So he reached out to Generac, trying to get it covered, and of course they denied him based on the age of the machine. So this is in non-running condition. He sold it for $100 as a parts machine. And in its current condition, it is definitely a parts machine. The starter recoil was removed, but it was included. We actually have that over there, so we can reinstall that. Also, the spark plug is out, and the valve cover, it's missing a few bolts. There's actually only two holding it on, and the issue is under here. The seller couldn't quite explain to me what the problem was, but there were a couple bags of hardware included with the machine. And one of those bags had a valve cover gasket, what looks to be a good rocker, and I would say a piece of the other rocker. So yeah, we do have issues in the top end. So I say we start there. Let me get you set up a little bit better. We'll get the valve cover off and just see how bad the damage is. I'm kind of hoping that we just have a bad rocker here, but potentially it could be a lot worse. Yeah, and it's a lot worse. Let me go in there and show you. So I was really hoping this was part of the other rocker, but that rocker is fine. And the part that broke is actually the part that holds this pin in place. So that is part of the head, and there is no way to fix that. This machine unfortunately needs a new head. And it's also surprisingly dark in here, so this might have a little bit more runtime than I was led to believe. And the valve wasn't stuck either, so whatever happened here, I would say it was just poor manufacturing. Yeah, unfortunately, there is no fixing this other than replacing the head. And I do have extra heads, but not Hemi heads. I have standard heads. So, technically we could convert this to a standard head engine, but that's going to have a ripple effect. I think the biggest just being the governor linkage and actually the exhaust as well. This exhaust, it's expecting a head of that length. So there is another option, actually two other options. We could just swap the engine. I do have some extra Generac engines. This is a 420cc engine, which can produce up to 7,500 watts continuous. So it's actually nice that they put an oversized engine on here. But I think we might have a better solution. We actually have this right here. This is a Generac GP5500. This is only a 390cc engine. So this one can only produce 6,500 watts, and it would be actually perfectly matched with what this is rated for. So we could do an engine swap. This one also has this Hemi style head. So, potentially we could just swap the head as well. But I'm thinking, since we have a good engine here, there's really no point in taking it apart. This machine also cost $100. And according to the seller, it doesn't make power. We're also missing the tank. So, this machine may or may not be viable. So I'm thinking, let's get this up on the lift as well. We'll just stick it on this end. We'll get the power head cover off, run some quick tests and see if that generator is salvageable or if it is a parts machine, in which case we'll harvest the engine and move it on over to this machine. I'm pretty sure this engine doesn't run currently, due to fuel problems, but the engine turns over and the guy did run it for a second on carb spray. So I know it is capable of running as far as the engine goes. So for now, we're just going to use a multimeter and maybe our eyeballs to see if there's any problem. And having this tucked in like it isn't ideal. Potentially that could knock the wires off the slip rings. But I think it's far enough away that it shouldn't have done that. And so far, everything looks good. All the lacing is intact. I don't see any burn marks. So the stator didn't have a meltdown, at least. Well, we might have gotten lucky here. I'm not sure I need a multimeter for this one. The brush on the left looks like it's broken. Part of it chipped off. And even if you look further down, closer to the plastic, it looks like it is scored, potentially, although not broken. But it is stuck. So there is a very good chance that this broke off. I mean, it definitely broke off, but without, the spring to push this onto the slip rings, there may have been no connection there. So let's get these brushes reinstalled. I'm just going to test with the multimeter to see if we're getting a reading from these terminals to the slip rings. And actually, before I do that, let's just test the rotor, make sure that it's good. And then we'll do the same test through the brushes and see what we get. Let's check the rotor real quick. I'm just going to use this multimeter. The main purpose here is just to make sure we don't have a broken wire. That seems to be the common failure on rotors. And if there is a broken wire, then this is going to stay at open circuit. But a healthy rotor with clean slip rings should come in between 40 and 70 ohms. So ideally, that's what we'll see here. And yeah, we're at 60 ohms. So the rotor actually seems to be good. Let's check it to ground. No ground fault. So the rotor is in fact good. Let's check the brushes real quick, at least electrically, to see if they're still connected properly to the terminals. Yep, so that one is good. Let's check the broken one. And yeah, electrically they're both good. So let's get these back installed and we'll do the same test of the rotor health through the brushes, which normally will add resistance. But we should still be probably less than 200 ohms. And we do get a reading. It's actually not that bad, about 260 ohms. But I'm guessing with that brush at the point like it is, it's probably not going to carry much current. And it's I would say, going to make a poor connection when the rotor is actually spinning. So I'm going to connect these alligator clips so we can get this connected without holding it. And I'm going to rotate the engine over and just see how much that value fluctuates and if it goes open circuit at any point. And it's actually saying it's open circuit now, which I'm not sure I believe. Huh. Okay, well, let's rotate the engine, see if we get that connection back. And I've got nothing, even after rotating the engine, so potentially these extensions are no good. And yeah, I would say bad test equipment, so I've got a whole bag of these. Let me grab 2 different ones, and we'll try this again. Incredible. So these are 2 different clips, and it's saying we don't have a connection. So is it the equipment? Interesting. Yeah, and we actually don't have a connection anymore. So that, I mean, that is the problem here. You know, that broken brush, it's not going to make a great connection, if one at all. And we did have a connection for a little bit, but it seems like it went away. So let's rotate the engine again. And we have nothing. Let's push on the brushes a little. And there's our connection. So yeah, broken set of brushes, that is an easy fix. And that's usually not the case. Usually this is a terminal problem. So let's get the bad brushes out. We'll get a good set in there, and we'll do the same test. I think those look right. The springs seem to work. So yeah, let's get these mounted up and see what we get. And these brushes, they only have 1 bolt. The other side is essentially a locating pin. So go easy when tightening the 1 bolt that you have, because it doesn't take much to strip this out. And if that happens, you need to buy a new end housing, which isn't cheap. So the bolt, it doesn't thread all the way in for some reason. So maybe someone already did chew up the threads. I mean, the hole goes all the way through, but the bolt actually didn't tighten the brushes up. So that could have been why the originals failed. So let me run through that with a tap. We'll try to clean those up, and hopefully that solves the issue. Same test as last time with the same alligator clips. Yeah, and there we go, 100.3. And I would imagine if you rotate it a little, you're going to get different readings depending upon kind of how the slip rings are situated. So yeah, that is perfect. This should make power, assuming I can get the engine to run. So I'm going to get the AVR reinstalled, and we'll swing this thing around and check out the engine side. So first things first, we'll check the oil. Make sure we have some. And yeah, it is filled up. The oil, you know, it's used. It could use an oil change, but it's perfectly fine to test with. So, you know, I say we make it earn its oil change. So let's take a look at the carb. So let's have a look in the carb. Not expecting it to look good. You know, the seller said the tank was a mess, and he actually got rid of it. So likely the carb is a mess as well. But the drain bolt and what comes out, it's going to tell us a lot. And actually, that looks pretty good. I don't see much in the way of corrosion or varnish, and nothing came out of the carb. So let's try feeding it a little bit of fuel, and then we'll try to start it. Although I will say the fuel that was on the tip of that bolt smelled pretty bad. And the throttle is not stuck, so it should be safe to try to start. The carb's accepting fuel. So that is a good sign. Hopefully that needle isn't stuck, which I don't think it is, because the flow, it's slowed down, although it hasn't stopped yet. I think we're in business. So let me lower the lift, hook up a light, and we'll give it a pull and see what happens. All right, let's give this a try. The ignition is already turned on. We are fueled up and we are not flooding over. So we're off to a good start. Get the choke on, and theoretically, this should start. Well, this generator, it was supposed to be a donor to fix the other one. That's the whole reason I had this here. And as it turns out, this one was an easy fix. You know, new set of brushes, about $1, maybe $2, and now it's making power. And not only that, but the carburetor is running pretty well. I mean, it started first pull, I could turn the choke off, and the engine ran perfectly. So this machine is perfectly viable, and really the only thing missing now is a tank. So I could likely steal this one, drop it on here, and call this one done. But I do plan on swapping the engine on that machine. So let's do that, and we'll circle back to this and figure out what we're going to do about the missing tank. So actually, let's change the oil. This has definitely earned it. My daughter has volunteered to pull the plug, so I'm giving her the small wrench first. She was wondering why I wanted to give her the big one, so she's about to find out why. So I'm going to go on record as saying it's very hard to get these bolts out, especially with just a normal ratchet like this. You just don't have the leverage. So unless you got some big muscles, really the best thing you can do is use a breaker bar or something that gives you more leverage. So even with something like this, I'm guessing an 11-year-old can get it off. So try this again. See? Was that easier?
Yeah.
So then you can use this to unscrew it. And you can let it fall into the pan. That's fine. Other way.
Oh, wow, that's hard.
And we'll get that up. And that's it. We just wait a few minutes and we'll fill it up with some fresh. And the oil that came out, besides being well used, actually looks to be in pretty good condition. There is no contamination, no gray color, no metallic or shiny bits in the oil. So the engine, I think is in good health. Anyway, let's turn our attention to the other machine. I'm actually going to spin it around so we can get better access to the generator. We do need to take that off as well as the exhaust before we can do the engine swap. And even though this engine's bad, at least has a bad head, I am going to change the oil out. I noticed it was kind of low, and it's coming out really thick. So I would say the quality of the oil in this machine wasn't great and potentially may have been a factor in the failure up in the head. So I'm going to start just by getting this tank out of the way. It's going to make the whole process a lot easier. So this is the vent for the tank and the fuel line. It's already disconnected, so we only need to remove the bolts in each corner. This should lift right out of the way, and we'll drop it on the other machine, just test fit it. This tank I think will fit, but that's not going to help us really because we only have one tank here. And yeah, the GP 6500 tank fits perfectly, actually, on the GP 5500. And although there is some old fuel in here, the tank is also in very good condition. So let's start just by disconnecting the generator from the control panel. And as you can see, this machine, it is absolutely spotless. Looks brand new. And this one's also wired better. So this connector is sitting outside, whereas on the other machine, this was kind of tucked in. This is really kind of the better way to do it. And just take note before you disconnect anything. So we have the red and the black wires here. These are the live wires, leg 1 and leg 2. The neutrals are actually bonded right here to ground. So, this is done a lot of different ways. A lot of times they'll run the neutrals over to here and then jumper the ground to the neutral. But this also works. Okay, so the control panel is free. Let's get the exhaust off next. And actually, before we shift gears to the exhaust, I'm going to pull this wire block, at least the 2 bolts, because ultimately we're going to have to get a puller in here, and the gap here is too small with the wiring block where it is. That should be good. Don't want to jinx myself, but these are probably the cleanest exhaust bolts I've ever seen, so I think these should come right off. And the next step here is just to free this end housing from the frame. So we're going to loosen it up, or actually remove these bolts and the grounding wire. And then I'm going to use some wood to support basically this side. I want this side floating. We'll get these rubber mounts out, and that'll just make things a lot easier when we go to slide the stator off. So now that we have the stator bolts removed as well as the end housing bolts, technically there's nothing holding the stator on except the ball bearing and maybe the bell housing. Sometimes it gets a little corroded in there. So you do need to use a puller, but you do not want to apply much force because the end housing, it breaks very easily. And you want to make sure you don't pull where the brushes go because there's actually a lot less material there, so that breaks almost instantly. And you shouldn't need much force. You can almost do this without a wrench. And if you do use a wrench, pick a very small one and apply very little force. You should know pretty much instantly because the force should not be building. And in this case, it's not. That stator's coming right out. So I'll try to tuck these wires out of the way. Unsuccessfully. Okay, wires are out of the way. We're going to get this rotor bolt out. And I guess there's a few ways to get the rotor off the machine. You know, what I've been doing recently is just loosening the bolt, then driving it most of the way in and using a 3-pound hammer to shock it off. You know, this is also threaded, so you could put a rod in there and a bolt and push it off. And you could probably use a slide hammer as well. I actually haven't tried that, but I think I'm going to use the bolt trick. That seems to be the easiest. So yeah, let's get that bolt loosened up a bit. We'll see if we can shock it off the tapered shaft. Okay, so we're about 2 turns out. And what I'm going to do is shock this now with a 3-pound hammer. Now, it's not always the best idea because if you miss, you're going to destroy the rotor. And sometimes, depending upon the generator frame, you can't get a good swing, in which case, you know, don't use this method. Use something else that's a little bit more appropriate. And no, this one's not playing nice, so I think we'll switch to a different method here. Let me see if I have any rods that are the right size. Or actually, I know I don't because this is the 10mm diameter bolt, and the rods I have are pretty much the same. So if I use that, it's going to push right into the threads on the crank and damage it. So let's actually use water to push this off. So I need to tip this up just a bit, and I added a strap so the engine doesn't fall over. The reason is when we put water in, we don't want air in there as well. So, you know, the more upright you can tip it, probably the better result you're going to get. So we get this full with water. And you don't have to use water, but the cleanup is a lot easier. You can use oil. You know, sometimes there's a bad seal between the tapered shaft and the rotor, so the water leaks out. But if you use a thick enough oil, you still might be able to build pressure. Okay, so we're as full as we're going to get. So we'll get a bolt in there. It's just an M12 1.75. And you do need a lot of Teflon. Usually more than I think. But the idea is you want to make a seal. So when you drive this bolt in, the water has nowhere to go, the pressure increases and eventually it will pop the rotor off the shaft. And this is probably the safest way to remove a rotor. And you'll know pretty quickly if this is going to work, because even when you thread the bolt in by hand, you should feel the bolt getting difficult to turn if it's actually making a seal and building pressure. So right there, I do see it leaking out, but I also feel it building pressure. So let's give it a try. We have about maybe 1/2 inch of threads before the bolt bottoms out. So worst case, we'll just reset and try it again. And it's as easy as that. So it's a very good method. It just takes a little bit longer to set up, but well worth the extra time. And only 2 bolts left. And then we can lift this engine right off the frame. We've got the old engine out, and the frame, it is bare. It is ready to accept a new engine, or in our case, a used engine. So let's make a trip to the storage locker and grab an engine that'll work for this frame. So the engines that'll fit on the machine with the bad head are kind of down here on the bottom shelf. This is probably the most obvious choice. This is a Generac engine, and I believe it's in good shape. I left myself a little note here that the carb does run rich, and this is the one actually I converted on video from a Hemi head, like the engine with the broken rocker, to a standard head. So I know this engine runs well. I believe it's 390 cc, so it's going to be limited to 6,500 watts at best. We have a Honda GX390 there. This one has electric start, but it does have the wrong type of tapered shaft. So that one we're going to have to pass on. The Briggs will not fit, has the wrong shaft. This Honda will fit, so this is a possibility. Also electric start, but it does have a bad oil sensor, so not my first choice. And I think the last one is this Lonsine. And this one runs, but it has a very bad knock. So I think the winner is going to be this Generac right here. So let's get this one back. We'll get it installed, and then we should be in good shape. So it's going to be interesting to see how this engine performs, being that it was a Hemi head engine like the one we took off, converted to a standard head, which I haven't done before. Now I have run this engine, but without a load on it. And at 390 cc's, 6,500 watts is the absolute best we can expect out of it. But some people in the comments said converting this from a Hemi to a standard that we were going to lose some horsepower, which I don't think is the case, but I guess we'll find out. going to torque that rotor down to 30 foot-pounds, but first we have to hold the crankshaft still. So I'm going to get the starter recoil off. We'll just get a large wrench on the flywheel nut to hold things still. Then we can go back to the other side and torque it down. And it's actually a good idea before tightening these bolts is to put the feet back on and let the stator down so that you know you're nice and level on the mounts. So let's do that now. I'm going to bring these up halfway first, and then we'll finish it off at 100 inch-pounds. So with the spark plug removed, it should rotate freely. The only exception is that the valve train is still connected. So as it pushes the valves open, you will feel and maybe hear that, which is fine. Just want to make sure you don't hear anything down in the power head. And we're perfect. So I'm going to get the plug back in. The next challenge is going to be that exhaust. So we'll start with the exhaust that came with this machine. And because the Hemi head is wider, I'm not expecting this is going to reach. Although it is closer than I thought, it's at least hanging on the studs. And depending upon how close it is, we might be able to get a spacer in there. So let's see if we can get a look at the gap. And hopefully you can see the gap there. So we're a good maybe ½ inch away from this exhaust working. So let's pull this one off. I've got 2 more we can try. And this one has the opposite problem. So we're about ½ inch too long, but this we can make work. Let me show you the gap. And you can see the gap right here. So we're about ½ inch away from the bracket. So we could use a spacer, a bushing, even just a nut of the right size. And this exhaust will work. That said, though, I have one more, so let's fit that and see if it's any better. And no, this one's too short, and it's not in the best condition. So I think we should go with the last one with a spacer, and this will be good to go. And there is already a new gasket on the head. So let me dig up the right size spacer, and I think we'll be good. So I came up with a bushing that theoretically is the right size. I guess the problem I'm going to have is that the bolt is now too short, and I actually don't like the fact that the walls are so thin. I think we'd be better off with something larger, like a nut. So yeah, I need to make a trip to the hardware store. I need to get actually a longer bolt and something a little bit more appropriate to space this. So I picked up kind of the perfect size bolt here and nut to act as a spacer. So if we can get that in, I think we'll be good. Yeah, I'm not liking the shrink tubing. These were close, but they seemed okay. But I'm looking at this from the Stator, and I'm just pinching the shrink tubing. And that's going to act as an insulator. Like, I want this to be electrically connected to the Stator, and you can see that one, especially, that shrink tubing goes all the way down right to the bottom of the ring, so that is no good. So I'm going to cut that back. And the others, they're not great, but I think if we're careful, it should be fine. Yeah, same problem on the neutrals. This one is very bad. And that one's passable, but I'm going to trim them both back. Just noticing the brushes just broke. Or not the brushes, but the actual holder. So it seems to be a common theme today. So brushes are good. The holder, not so good. So we'll get a brand new set of brushes on, and these actually have a metal bushing, so there is virtually no way to over tighten it and crack it like we just did. And that's it. Theoretically, we should have a running engine that has a working generator. So let's feed the carb a little fuel and see what we get. I was about to say we're all fueled up and ready to go, and then I tried bumping the throttle. I wanted to make sure it wasn't stuck, and this one is stuck at wide open throttle. And the interesting thing is the plate itself isn't stuck, it's just hyperextended. So if I help it a little, now it works fine, but if I let it snap back to full throttle, then we're locked again in wide open throttle. So, this carb I was going to swap out anyway due to the note here that it runs rich, but it also has a fuel solenoid, which we don't need, and the wrong type of choke. So I'm going to grab the carb from the other machine and put it here, since that is a perfect replacement. And I actually have different plans for the other machine, but we'll circle back to that later. And I'm guessing we might need to recalibrate the governor on the other side, or at least double check it to make sure that, we're not going to have problems controlling the engine speed. I'm pretty sure I reset it using that carburetor after I rebuilt that engine. So the quick and dirty check on this is to hold this in wide open throttle, and the governor spring is already holding this in the wide open throttle position. That's low speed, this is high speed. And when at high speed and set to wide open throttle, this 90 degree should align with the hole that drops it into the car, but we're actually off. That hole is right there. So yeah, we need to recalibrate. And for that, we are going to lock this in. And once we get that in place, I'm going to loosely, or I shouldn't say loosely, I'm going to snug up the carb, against the manifold, and then we'll loosen the bolt on the governor arm and make that adjustment. So before you do anything, make really sure you know which way full throttle is. The idle set screw is there, so if the plate is in that position, you're in the idle position. In this case, the plate has to rotate counterclockwise to reach wide open throttle. And this right here also rotates counterclockwise. So what we need to do is loosen up this bolt, hold the governor arm in the wide open throttle position, and then rotate the shaft counterclockwise until it stops. And it's going to be a very fine adjustment, but once it's done, you can snug that up. And then we'll do the same test, just see if the calibration is closer, if not perfect, as to the alignment of that 90 degree to where it drops into the carb. And another thing I should add too, there's also a pin that goes through the shaft. So when you loosen this up, the shaft shouldn't fall into the engine, but if that pin is rusted away or missing and you loosen this up, this shaft would just drop right in. And at that point, you have to open the engine to fix it. Anyway, let's loosen that up. All right, so we're loose. And you might have to pry this open a little bit before the shaft will turn. But let's try turning it first. See if it moves. And yeah, it is moving. So right there, we should be good. So we'll snug that up and double check. So we'll get the governor rod disconnected. And then we can slide the carb back in. The spring is holding this in wide open throttle. So the rod's already in the right spot. The throttle, we want to hold in wide open throttle. And we want to see that these align. And it aligns perfectly. So the governor, it is calibrated. So we'll get this back on. Tighten everything down. And I think we'll be good. If I can get this back on. There we go. And we'll leave the airbox off for now. Until we know this works properly, there's really no point in finishing it up. Well, it's the moment of truth. Ignition's on, choke's on, we are full of fuel. And we also have a light plugged in and turned on. So let's give this a pull. Let's see what we get. So we are 2 for 2. We now have 2 Generacs, both running and making power, although not at the same time. We are missing a carb now on the other machine. And this one, although the carb ran it, it was actually running it lean. The engine was surging just a little bit. So I think it's unavoidable. We're going to have to clean the carb, which usually we do. So I'm going to start here. I want to get this machine finished up. So we'll clean the carb, get it running right, get it fully back together, and then we'll turn our attention back to this machine. So let's have a look at this carb. I've pulled it off the machine, and I'm sure this carb does need a clean. I guess the thing that concerns me is that when we ran this carb on the other engine, it ran it perfectly. So certainly a dirty carb would be one reason, but the inconsistent results, tells me that it's likely something else. And we actually ran this with the airbox on the first generator, but airbox off on this one. So that could definitely have something to do with it. But the fact that this bolt is on there pretty good too isn't a good sign. I guess the other possibility is the porting. They do have different heads. So if one engine breathes better than the other, then that would make a difference in the jetting. And the same thing for the exhaust. So potentially there's more back pressure on the first engine we ran than the second. Yeah, a little bit of junk on there. Not terrible though. And yeah, it's pretty good. Yeah, I've seen far worse. This is actually pretty clean. So yeah, we'll soak this in the ultrasonic anyway. But I'm thinking, we might have a difference here in back pressure. And ultimately, we might need to drill out the pilot jet to get this to run right. And this right here is the pilot jet. So this is why it was surging. This is what meters the fuel when there's no load. So if we increased that jet size just a bit, that surge for sure would go away. And the last thing we have here is the main jet and the emulsion tube. And that is coming out. Okay. And that's it. So I'm just going to go through the passages real quick. We'll soak this for 5 minutes, put it back together, and we'll try it out. Yeah, and the pilot jet, it is clear. Main jet was also clear. Emulsion tube, also good. So yeah, no smoking gun on this one. So the carb cleaned up pretty well, although it was already clean. So yeah, I think it's going to run the same way. I also took a second just to look at the throttle plate to see why the other one was kind of hyperextending. So this is the good carb, and when you open the throttle, it goes that far, and that's it. And there's actually a plastic piece right here that acts as a stop, so you can't rotate it any further. Well, if you look at the carb that was originally on this machine, this is essentially idle, and then full throttle, but you can keep going all the way around until you reach idle again. So that was the problem with this carb. And there is a stop like we have over there, at least a metal one, but the piece of plastic coming down from the throttle plate, that just broke off and is nowhere to be found. So like that, this carb can't be used unless you swap out the throttle plate shaft. Anyway, let's get this one back together, and I'm going to bolt it back on without the airbox. I want to see if there's any difference after cleaning, and assuming there's not, we'll add the airbox, try it again, and based on what we see there, that'll kind of determine how we fix this problem. And these pilot jets, they don't like to seat without a little help. I'm going to put just a little bit of WD-40 on that bottom O-ring. And yeah, same exact thing. So if that's not all the way down, besides creating an air leak, you're going to have trouble getting the idle set screw in place. I think we got it. And this generator does not idle, so only turn this in enough to hold the pilot in place. So usually just 1 or 2 threads poking out the other side, like that, is all you need. So I'm going to bolt this back on. You've already seen that done at least once or twice, so I'm going to resume the video when we're ready to try this out. All right, let's give this another try. The carb has been refueled. It's obviously reinstalled, and the airbox is not on. So it's pretty much the same as before as far as the conditions go. The only difference is we did clean it. So let's see if it'll run without surging. Interesting. Well, it seemed like we still had a bit of a surge, but I did shut it down prematurely because I thought we were having power problems based on what I saw on the light. But then I just grabbed the bulb and it kind of unscrewed itself. So that is a bit of a false alarm. So I'm going to refuel. We'll try this again. All right, same test as last time, although I realized I didn't torque the carb down. So it might run a little better if that's done. All right, so the carb is torqued down, and this time I'm going to run off the external tank. So let's get it restarted, and we'll see how it does. That was it. Yeah, I guess that did it. So the first time I started it after cleaning it, the carb was not torqued properly. So the surging was due to that. And of course the power issue ended up being a non-issue. So now that it's torqued properly and that we're feeding it fuel, it ran perfectly smooth. So I think we can finish this up. I'm going to get the airbox reinstalled. We'll get the tank put back on as well as the end cover. And we can call this one done, at least done enough to get it outside for a test. The one over here, though, we still need to do a bit of work on. So let's secure these before getting the cover back on. So this zip tie just has a hole here for the bolt. So it'll securely kind of hold these wires out of the destructive path of the rotor. And sometimes you can add like a second one further down just to make sure. Yeah, so that should be good. They're not gonna go anywhere. I think the last thing we need to do here is just drain the tank. Not a lot of fuel in here, thankfully, and the fuel, although not fresh, I wouldn't say is terrible, but it's definitely a little bit past its prime. So we'll get that out. If the fuel valve turns, and it's kind of gummy. And we're not actually getting any flow. Oh, there we go. Yeah, actually we are getting good flow. So give this a few minutes, and once it's done, we will secure the tank and make the final connections. And last but not least, the protective blue plastic. Now it's been on here for 13 years, and unfortunately, it's past its expiration date, so it doesn't like coming off when it's this old, especially if they're left outside. This machine, I think, was stored indoors, so there is a chance this will just come right off. So this one I think we're done with, at least for now. And that brings us to the remaining generator. I don't have a tank for it, but what I do have is a tri-fuel carburetor. I actually tried one of these out about a year ago and really expected it to fall on its face, but it actually performed quite well. So I'm going to get this one installed. We'll give it a quick try, and assuming we're good, then we can finish up this one as well. So in our case, we're going to run this on propane, so make sure you select that. And I'm not planning on running it on gasoline, so we do need to put like a vacuum cap here. Otherwise this will be an air leak. So going to test fit it. Mostly I want to do the governor check like we did on the other machine. So that is wide open throttle. We'll hold it right there, and the governor linkage is already in that position. And you can see we are off just a bit. And that still might control the engine speed, but it ideally should be right there. So I'm going to connect this. We'll also do a governor reset on this machine. And then we'll try this out. All right, let's see where we ended up. Doesn't have to be absolutely perfect, but I do like it probably within 1/8 of an inch of perfect. So the governor rod, it's being held in wide open throttle by the governor spring. And if we rotate the throttle plate, you can see we're much closer than we were before. It's not perfect. Ideally it would drop down in. But before, we were something more like that. So yeah, I think that's going to be good enough. So I actually need to add a gasket there, so let's throw that in, and we'll get everything secured and try it out. I take that back. There actually is a gasket already there. So I'm going to eliminate this cap. I don't see taking this line on and off. And potentially I might convert this to a quick disconnect. But for now, we're going to run what we have. So we'll get this connected. This is just a standard grill regulator. It's limited to 80,000 BTU, which is about 8 horsepower. So it's not really appropriate for this machine, at least not for loads over 4,000 watts. So we're just going to use this to test with. And if everything goes well, I'll just order up a higher capacity regulator. And there's actually a lock-off valve in here as well. So when the engine's not running, the propane doesn't flow. It needs engine vacuum. So if you don't purge the line and you try to start it, you're not going to have a good experience. So I just purge it until I smell propane, which I do right now. And then I give it a couple minutes because, likely the engine's flooded. So after maybe 2 minutes, should be good to go. All right, let's give this a try. Ignition is on, propane's already on, and I'm gonna close the choke, although if it doesn't start in a pull or two, it's kind of easy to flood the machine out. So let's give it a try. Now, propane can be very hard to start a machine on. The last one I tried of this particular carb actually was one of the easiest that I've ever used, so I'm hoping this one is as good. Beautiful. Beautiful. So the carb, for 40 bucks, you really can't beat it. Theoretically, you can run on gasoline, which I've tested. It runs well. Propane, which obviously works well. We just saw that. And natural gas, which I don't have access to, but if it runs as well as it does on those other two fuels, this is a great deal at 40 bucks. Anyway, I think we're at the point now where we can finish this up. So let's get the airbox on, probably get the handle back on as well as the end cover. And then I think this one will be ready. And the best thing about this kit, besides the price and how well it works, you actually are using the original form factor. There are some kits where you actually have to cut the frame rail to get it to fit, or insert like a snorkel. And when you do that, it actually pushes the carb out, which causes problems with the airbox hitting the frame rail and also just running out of length as far as the studs go. Interesting. So the airbox, at least the bolt, isn't threading in. It looks like the threads are completely missing, but it is a through hole. So, we can, I guess, substitute this nice knob for just a long bolt, and it should be fine. So I'm just going to get this fuel solenoid wire secured kind of out of the way of the governor linkage. I mean, technically, we don't plan on using this. You could probably just cut it off. But you never know what someone might want to use it for in the future. So we'll leave the wires intact. We'll just plug this into itself. And that is all set. And I think we can get this tag off because it's no longer a $100 generator. So everything is secured. Ideally this would stay out from inside of here. This is how it was originally. Like that, it is actually out of harm's way. What you don't want is that, this kind of moves toward the rotor. In this case, it's right up against the housing, and it's actually kind of locked in there. So I think we'll be okay leaving it like that. All right, it is the moment of truth. We've got both machines out here ready to go. I'm going to start with the propane generator. I guess the question is, will either of these machines reach its rated load? And that I am not sure about. This engine is a 390cc engine and should easily get up to 6,500 watts when running on gasoline. Of course, we're running on propane, so we're going to lose about 10% of the horsepower. But even so, that is about 5,800 watts. So I think we should be able to reach its rated load of 5,500 watts. The machine over here, I'm a little bit more leery about for a couple reasons. This, like the other machine, is a 390cc clone of a Honda GX390. And technically, those engines should be able to produce up to 7,000 watts. But I've never been able to get that. And even 6,500 watts is a stretch. Usually I fall a few hundred watts short. And given that this engine was previously blown up and dropped a valve into the cylinder, and we ended up rebuilding it with spare parts and swapped the head from a Hemi to a standard, there's a lot of unknowns on this machine as far as how it's going to perform. But if we can at least get to 6,000 watts, I will be pretty happy. So let's get the propane generator started. We'll double check the outputs, then we'll put on a half load. And if everything looks good, we'll go for the max of 5,500 watts and see how it does. So no issues at all getting this machine started, but the no load speed, it is slow at about 58 Hertz. That needs to be closer to 61 and a half. So I'm gonna make a quick adjustment and then we'll put on the load. I forgot to mention before getting the machine started, I swapped out the propane regulator with one that is rated for 220,000 BTU. So that is good for up to 22 horsepower. So we made a small adjustment and the engine speed is now about 61 and a half Hertz, no load. Without a load, THD isn't too bad at 5.3%, and the sine wave is pretty typical. It is jagged, but that should clean up a little bit under load. So let's put on a 2,500 watt load, starting with 2,000 watts. No issues. Now we're at 2,500. Engine speed is stable, and the THD jumped quite a bit to about 16%. And the sine wave, not as jagged, but definitely a little deformed. So we'll give this a few minutes, and then we'll go for the max of 5,500 watts. Alright, so it's been about 5 minutes, no issues at all at 2,500 watts. So let's bring up the load to the max. We're going to swap a 500 for a 2,000. So now we're at 4,000 watts, 5,000, 5,500, and we're doing pretty good. We're at 59 Hertz. THD jumped again. We're at 19.5%. And the sine wave looks about the same. So let's go for a little bit more. Let's try 6,000 watts on propane, see what happens. Yeah, it's actually doing 6,000 watts, so that is pretty good. So let's go back to 6,000. Let's try 6,500. And no, it's out of power at 6,500 watts. So I'm going to bring the load back up to 5,500, and we'll just give that a few minutes, make sure there's no surprises. Well, it's been a few minutes at 5,500 watts, which is the rated load. no issues at all. So I would say the propane generator is a pass, and it actually handled an overload of 6,000 watts as well without issues. So that is actually pretty good. So I'm going to take the load off. We'll give this a couple minutes to cool down, both the load bank and the engine, and then we'll shut it down and swap over to the other machine. And we've got the other machine all plugged in, ready to go. So let's get the engine started and see exactly how much power this machine can make. So like the other machine, it started right up, but the engine's also slow at about 60 Hertz. So let's bump that up a bit, and then we'll put on a load. So with that adjustment, we're now at 61.5 Hertz, give or take a bit. And similar to the other machine without a load, we're starting out at around, I'd say about 5%, although it is fluctuating more so than the other one. And the sine wave, it is jagged. So let's start putting on a load. We're going to start with 3,000 watts. So there's 2,000, no issues. 3,000, the engine's holding nice and steady. And the THD did jump as well to 17%. And the sine wave is no longer jagged, but it is a little bit deformed. So let's give this a few minutes. Assuming there's no surprises, we'll go for the max of 6,500 watts. Alright, so it's been a few minutes, no issues at all, pulling 3,000 watts. And surprisingly, the engine speed is holding very stable. You know, under essentially a half load, we're at 61.3 Hertz, so that is actually pretty good. So let's bring the load up a little bit more. Let's swap 1,000 for a 2,000. So now we're at 4,000 watts, 5,000, 5,500. 6,000. Yeah, it's actually performing pretty well. So let's swap these and we'll bring it back up to 6. How about 6,500? Yeah, it's holding 6,500 watts actually very well at 61 Hertz. THD is at 21%. And the sine wave doesn't look great, but it is typical. Anyway, let's go a little bit more. Let's see if we can do 7,000 watts. Yeah, no problem there. So let's swap these two for 1,000. So we're back is the most it can possibly do. And in this case, we just did it. Anyway, I'm going to bring this back to its rated load of 6,500 watts and just let it run for a few minutes and make sure there are no surprises. No issues at all pulling its rated load, so we'll take the load off, and we'll let the engine in the load bank cool down, and then we'll shut it down. Well, guys, I think that's pretty much it. Going into this, I had 2 broken generators, and the plan was to combine 2 bad into 1 good. And as luck would have it, we were able to repair both of these machines, and they are running quite well. Each one can now pull its rated load, and they both handled an overload of up to 500 watts, which is really good. Not all generators can make that claim. So, these engines are running, I would say, as good as they possibly can. Anyway, as far as the original engine that was on this machine, I wasn't planning on rebuilding it, at least not buying new parts to rebuild it, because the OEM head from Generac sells for between $400 and $500, and this machine likely isn't even worth that kind of money. So I was going to wait around until another engine showed up as a parts engine. But I took a look on Amazon, and there is a brand new Hemi head 420cc that is marketed for a Predator engine, which is also a Honda clone, and that one is selling for just over $100. And I see no reason why I can't use that head to repair a Generac engine. So I've already ordered that up. Should be here in a couple weeks. So there will be a rebuild attempt on that soon. So until then, I hope this video helps someone. Thanks for watching.